For our first example of verifying trig identities, we're going to look at cotangent of theta plus 1 equals cosecant of theta multiplied by cosine of theta plus sine of theta. Now, if you remember, when you work on these, you're only allowed to work on one side. So we have to pick a side to work on. And I think we talked about this before, but when you pick the one that looks worse. If you pick the more difficult side, it will be easier to condense it into something simpler than it will to take a simple side and expand it out into something more. Make sense? So which of these sides, left or right, is more complicated? Right. The right side. So we're going to start on the right side. We are going to draw a line down the middle to avoid us. You're not allowed to cross this line, okay? We're only going to work on the right side, and we're not going to stop until it looks exactly the same as the left side. So one thing I notice about the right side is it has parentheses, and the left side does not. So let's get rid of those parentheses. We can distribute. That's one of the things we're allowed to do, right? You're basically allowed to do anything algebraically that you can do to just one side at a time. So let's distribute. Cosecant times cosine plus cosecant times sine. And be sure you carry your angle through with you the entire time. All right, at this point, I have two terms, which is good. I'm aiming for two terms, and I'm hoping that one of those terms equals cotangent of theta and one of those equals 1. The best way to look and to compare cosecant to cosine is to change the cosecant to 1 over sine, right? Okay, so let's do that. I don't know what else we could try, but let's go ahead and let's change everything to sines and cosines, and we'll change this to 1 over sine, and that's times cosine. And we'll change cosecant here to 1 over sine as well, using our reciprocal identities. And then we'll look at each term separately and see if we can clean it up. Do you notice that this right here becomes cosine over sine, which is good? So we have cosine over sine. So we simply multiply them together. Now what does this one become? 1. Just 1, yeah, the signs cancel. So it becomes 1, which is good. We can see the plus 1 on the end there. If you know your quotient identities, you should also recognize that cosine over sine is cotangent. Once the left side and right side are equal, you stop. And what will be graded on these when you're asked to do them is your work. So you have to have legitimate algebra at work there. Okay, you can't just like scribble a bunch of junk and then write the final answer. Although you might get away with that occasionally, you know. So if you don't know, try something, you know, and see if maybe it makes sense. But basically, I'm grading for your steps. So the way I'll give partial credit is even if you don't quite get all the way to the other side, you know, if you have 2 or 3 legitimate algebra steps and you're making progress, I can give you some points for that problem. So do something, never leave it blank. Okay, so for the second one, we have tangent squared of x multiplied by 1 plus cotangent squared of x is equal to 1 over 1 minus sine squared of x. So they're both a little more complicated than the one before. Agree? Yes. Okay. But I tend to think the left side is more complicated simply because it has more trig functions in it. And so if I think, you know, they kind of look equally complicated, I will choose the one that has more trig functions. The right one only has sine, but the left one has a tangent and a cotangent. And I tend to think sine is simpler than tangent and cotangent. So I'm going to work on the left side this time. What do you guys want to do? There are several options. We could distribute. Who recognizes also that 1 plus cotangent squared is equal to cosecant squared? I do as well. I see that Pythagorean identity. You will get the same answer regardless, you know, so it's up to you. So tell me what you want to do here. Go ahead and change it to cosecant squared. Okay, so we are going to use the Pythagorean identity, and we're going to replace this piece right here. So we're going to keep the tangent squared, and we're going to replace this piece in parentheses with cosecant squared. So really we have tangent squared of x times cosecant squared of x. And then we're kind of stuck. Any ideas?
Change it to sine, because we know we have to get to sine.
Yeah, we know we have to get to sine, right? So a good idea is just to go ahead and change it to sines and cosines.
Right.
All right. So tangent is sine over cosine. So tangent squared, you're allowed to alter those exponents and make it sine squared over cosine squared. Now remember, you're allowed to alter the exponents on the reciprocal identities and the quotient identities. So you are not allowed, however, on Pythagorean. They have to stay squared. So you're not allowed to take them off or put something else on. Cosecant squared can be changed into 1 over sine squared. Okay? Well, the good news is the sine squareds cancel. One on top, one on bottom. They reduce to 1. And I'm just left with 1 over cosine squared of x. All right, I'm starting to make progress because I see now that it's in the right form. I have 1 over something. But now we have to convince ourselves that cosine squared is equal to 1 minus sine squared.
Yes.
I believe that it is. Why do you believe that it is?
It's
Sine squared x plus cosine squared x equals 1. So it's like you just subtracted.
Right, it's an alternate form of your Pythagorean identity. So I'm going to come up here just to make sure everybody understands that. Off to the side, we know that sine squared of x plus cosine squared of x always equals 1. Well, that's only one way I could write that. I could rearrange that Pythagorean identity, and I could get cosine squared by itself by subtracting sine squared from both sides. So it's also true then that cosine squared of x has to equal 1 minus sine squared of x. So I am allowed to substitute in the place of cosine squared 1 minus sine squared because of that Pythagorean identity. So we'll come back over here and we will rewrite it instead of cosine squared as 1 minus sine squared. And that's something that'll take you a while to get used to, but you do need to recognize what we call the alternate forms of that. It's also true that sine squared is equal to 1 minus cosine squared, right?
Yeah, so could you have left it like 1 over cosine?
You can't stop until the left and right sides are equal. So you're not considered complete until your final answer is equal. So once these two guys are the same, that's how you know you can stop. And they are exactly the same now. Any questions about this identity? What have we just done? We have verified, right? We verified that these two sides are equivalent. They didn't look like they equaled each other, but it turns out they really do. So we've proven that that identity is in fact true. There are infinitely many, I say infinitely many, maybe not infinitely many, but it certainly seems to be. There are tons and tons of identities in Trig. We have you memorize a few of them, and then we use those to prove that others are also true. Okay, for example 3, we want to verify that tangent of x minus cotangent of x, all divided by sine x times cosine x, is equal to secant squared of x minus cosecant squared of x. I don't know about you, but they both look pretty gross, right? Both sides? Okay, so the left side has how many trig functions? 4. And the right side only has, let's start on the left. It's going to be easier to turn 4 trig functions into 2 trig functions than 2 and expand them out into 4. So let's start on the left side. Okay, as we come over here and start on the left side, I notice that I have a fraction over here and not over there. Did y'all see that? In fact, I have 2 things subtracted over there. So to me, it sort of makes sense that maybe what we should do is separate this big fraction on the left into 2 separate fractions. Do y'all understand that you can do that? Okay, let's try that. I don't know how it's going to work out, but let's try it. Let's take the tangent of x over sine times cosine, and let's separate it from the other, minus cotangent of x over sine times cosine. And do not leave your angle off. You have to put the x with every trig function. Now, as it stands right now, it's not getting a whole lot better. But I do know that if I change the tangent and cotangent to sines and cosines using their reciprocal identities, that maybe something will cancel. I mean, not the reciprocal, what are those? The quotient identities? Yeah, the quotient identities. That maybe something will cancel. So you guys want to try that? Yep. Okay. So let's rewrite the top of this one as sine over cosine. So sine of x divided by cosine of x, all divided by, well, that was weird, all divided by sine of x times cosine of x. And I'm going to do the same thing with the other fraction. I'm going to change the cotangent of x to cosine of x over sine of x using my quotient identity. And it's all going to be over sine of x cosine of x. Okay, so there's where we stand now. I don't know how comfortable you are with these. I don't have a clue. Like, I really don't know. Do y'all know how to clean that up? You don't? See, you're not.
Miss Hughes.
1 second, please.
Yeah.
Alright, so at this point, we have to figure out what to do with those fractions, and there are a couple of ways we could handle it, but for now, let's think of it this way. If I put the bottom fraction over 1, then it looks like I am dividing two fractions, and the way you divide two fractions is you keep the top and change the bottom to the reciprocal and change it to multiplication. So now we have sine x over cosine x multiplied by 1 over sine x cosine x. And for the other fraction, we have cosine x over sine x multiplied by 1 over sine x cosine x. Once we see it that way, we can see that these signs cancel, and we're left with 1 over cosine squared of x minus, and over here what cancels?
1 over sine squared.
Cosines cancel, and we're left with 1 over sine squared. Well, if I take a look at the other side, I would like it to equal secant squared minus cosecant squared. The nice thing about it is that it does. If I apply my reciprocal identities and substitute, 1 over cosine is secant, so 1 over cosine squared is secant squared. So it really helps to look at the other side to kind of guide you, as you go to see what you should do. So this is minus cosecant squared. And once the two sides are equal, you can stop.